Hello, and welcome to this video about polymers in fashion and clothing. Polymers, also known as macromolecules, are large molecules consisting of linked together repeating units, which are known as monomers. Two monomers join together to form a dimer, three monomers join together to form a trimer, and if many monomers are joined together, this is known as the polymer. This example shows polyethylene, a polymer made from linking ethene monomers. Did you know that the likelihood that you're currently wearing polymers is extremely high? And why is that? This is because some of the most common materials and textiles used in clothing are polymers. Historically, natural polymers such as cotton, silk and linen have been the basis of many clothing items. Cotton has been used as a fabric for over 7,000 years and is produced from the raw cotton plant. There are limitations of using natural polymers, such as the growing process, and with developing polymer science, many new synthetic polymers are now used to overcome these limitations. Today, we use many synthetic polymers for our clothing, such as nylon, Kevlar, and polyester. All of these have differing properties caused by their differing polymer structures. Synthetic fabrics usually have a higher strength, lower manufacturing costs, an easier designing process, and a better appearance. However, are they having an adverse effect on our environment? We'll think about this later in the video. Here is a summary of different properties of natural and synthetic fabrics. You can pause to read more. Let's think about cotton. Cotton fabric is produced from cotton plants, therefore its polymer is naturally occurring. This makes it biodegradable and hypoallergenic. The fibres in cotton are 90% cellulose, a polymer made from beta-glucose monomers. Cellulose forms ribbon-like strands of beta-glucose monomers. The monomers are linked by beta-1,4 glycosidic linkages, indicated by the arrow. Hydrogen bonding can occur between the molecule itself and also between parallel cellulose chains. This gives the material strength. The gaps between linked chains allow air to pass through, making cotton a breathable material. Hydrogen bonding can also occur between the hydroxyl groups of cellulose and water molecules, making cotton absorbent. In fact, there are so many hydrogen bonding locations that cotton can absorb between 24 and 27 times its own weight in water. The absorbing of water disrupts the cross-linking structure of cotton, causing the material to crease. Its high absorbency means cotton creases easily. As you can imagine, the absorbency of cotton makes it very unsuitable for use in swimsuits. So what would an appropriate material look like? Nylon is used in swimsuits, along with blends of nylon, polyester and elastane. Nylons are produced from dicarboxylic acids and diamines. For example, this diagram shows nylon 6,6, which is produced from 1,6-hexane dioic acid and 1,6-hexane diamine. Hydrogen bonding can occur between the hydrogen of the amine group and the oxygen of the carboxyl group on a parallel polymer chain. This means the material has a high stability, so is strong and durable, with a high tensile strength. Hydrogen bonding can also occur with water molecules, making the material slightly absorbent, but significantly less than cotton, as there are less sites for hydrogen bonding to occur. Nylon blends, for example with elastane, are often used in swimwear to increase the elasticity. Elastane is a copolymer, a blend of polyurethane and polyethylene glycol. Elastane is an alternating copolymer of soft rubbery segments and rigid segments. The soft rubbery segments are polyethylene glycol, a highly flexible segment that provides the elasticity, whereas the rigid segment is made from polyurethane, which is strong due to its aromatic rings. The polyethylene glycol sections are disordered and make the fabric soft, whilst the polyurethane section can bond with each other to give a rigid crystalline structure. When a stretching force is applied, the bonds between the rigid sections can break, allowing the soft section to extend and lengthen the fibre. Upon removal of this force, the soft sections can recoil to their original position. This makes the fibre elastic. One of the most common materials used in clothing today is polyester, most commonly polyethylene terephthalate. Polyester fibres are incredibly strong and durable due to the large aromatic ring in the polymer structure and the close packing of the chains. It is water resistant as the ester groups are neither hydrophilic nor hydrophobic, giving it a low absorbency. This also makes it wrinkle resistant. It is also a non-biodegradable material. Most waterproof clothing now includes a waterproof material sandwiched between other fabrics. This material tends to be PTFE, polytetrafluoroethylene. PTFE is made from tetrafluoroethylene monomers. The carbon-carbon and carbon-fluorine bonds are very strong, and the fluorinated surface makes it very slippery. This prevents interactions from forming with water molecules on the surface, making the material very waterproof. This material has been adapted into expanded PTFE, or ePTFE. This has tailorable porosity, making it great for breathable yet waterproof outdoor wear. This is because ePTFE allows water vapour, or sweat, to escape, yet water droplets can't pass through. It is also very lightweight, flexible and strong. There are, however, some ethical and environmental issues surrounding the production and disposal of some of these polymers. Cotton requires a vast amount of water to produce, with a water footprint of almost 10,000 metres cubed per tonne, which works out at over 10,000 litres per kilogram of cotton material. There are also concerns about the low income of cotton farmers and child or forced labour. Fast fashion takes advantage of synthetic materials such as polyester and nylon to produce a large amount of items in little time. Fast fashion encourages disposability, where garments are so cheap it almost feels okay to throw them away after a few wears. This is a huge problem for the environment, as over 300,000 tonnes of clothing ends up in landfill each year in the UK. If these clothing items are made from synthetic polymers, they'll most likely be non-biodegradable. Alongside this, the fashion industry produced 2.1 billion tonnes of greenhouse gas emissions in 2018 alone. With the rise of fast fashion, this is estimated to rise by 50% by 2030. There are, however, some potential solutions to these problems. A research article has been published that believes a new fabric can be made from polyethylene, the polymer in plastic bags. If successful, it could reduce the carbon footprint of the fashion industry and reduce the vast amount of non-biodegradable plastic we have on our planet. The material would also be easier to recycle, as it would only contain one type of polymer. There are also some things that we can do as consumers, for example by fixing, repurposing or recycling clothes, or selling them on sites such as Vinted or Depop, or giving them to charity. You could also look into buying clothes that are made to last, and avoid buying clothes just to keep up with the trends. There is a link attached if you want to learn more. Finally, here is a list of references used to produce this presentation. Thank you for watching.